Well, hello there, YouTube. I haven't posted a video in a little while. I spent a lot of time working on the monster. You guys have seen that. It hasn't changed much. What I've been working on is this. It's a bipolar solid-state Tesla coil. Ordered it on eBay, shipped out of China, and it completely didn't do what it said it was going to do. In the pictures, it was blowing an arc from ball to ball. 30 centimeter arc output. It was doing like that. And it all came smashed up. I mean, look, I had to glue a lot of the plexi back together. The customer service was crap. Trying to get, at least a partial refund, something, because I mean, it really does look like crap compared to what I wanted it to look like. Of course, beautiful, display worthy. As it is, you know what? It's a lot of fun. And I've pretty much reworked a lot of the guts in it. I don't know, and I've even seen other videos on YouTube where, people had the same coil and they had the full output that they advertised, and I mean, they're badass. Well, I rewound the primary with 3 turns of fat wire. This is the primary winding that they sent me. It's like silk covered. The silk wrapping was ripped. So you can see the copper through it, and it only had 2 turns. It wasn't right. So that was a big improvement. I also added some capacitance to the top loads. Those on the very end there are baby food jar lids. On the inside here, I don't know if you can see that little metal disc right in there. That's just another plate, another disc that I added in there to, form plates in a capacitor, hold some juice. That helped. Still there again, it wasn't, massive groundbreaking. It also came with, this is 2 rods. That way this could be, 1 length higher. This would be 1 length higher. Taking 1 rod out, I noticed, seemed to help. There again, very little, but it was an improvement. The biggest improvements by far was the rewinding of the primary. I don't know if you can see in there my beautiful gate drive transformer. That was pitiful. The thing China sent me was not Bipolar wound. The windings were all just super thin wire, hodgepodge together, just absolutely. I can only imagine what the gate drive waveform looked like with that transformer in there. That was a big improvement, I have to say. Another thing I did, being that I'm here in the United States, is I ditched on the input, 120 volt, I ditched the full bridge rectifier IC, just everyone's seen them, little chip with 4 posts on it. I ditched that and I put in a full wave voltage doubler in its place, which a voltage doubler uses 2 diodes, 2 capacitors, and basically it full wave rectifies. So it does exactly what the full bridge rectifier was doing, but it boosts the voltage to double. And I did that without having to modify any of the, internals. It's pretty much set up to where if you had ordered this and asked them to make sure that it would work in a 220 country, they would just do a very simple modification to it. Specifics on that I don't know, but it's basically either or, ready to go. And I run it through my Variac, cranked all the way to the full tit. So it's 150 volts. doubled, and that's what I'm running on the high voltage side. Of course, the low voltage driver side is still 5 volts and 15 volts, regulated with 7815s and 7805 voltage regulators. The drive, what it came with for a drive circuitry, it came with a CD 74HC132E IC, which is just a high-speed CMOS logic quad, NAND with a Schmidt trigger. It's a like a hex inverter. It's a dual inline pin, 14 pin IC. I don't really know much about that one. It hasn't given me any problems though. And then for actual drivers, I have two TC4422s. They're dual inline pin, DIP 8s. I have two of them, one for each IGBT. They're 9 amp high speed MOSFET drivers, and they're pretty well bulletproof. They can source and sync up to 9 amps, which is plenty for what you. I mean, they can drive some of the biggest MOSFETs and IGBTs around. Plenty for what I'm trying to do here. And then the gate drive transformer, you guys already saw that through the case there. I reused the stock core. I did experiment with different cores, but that stock core actually gave me the nicest waveform for what I was trying to do. It's just a green core, which in my opinion is not really the best. If it had been a light blue core, I've seen a lot of other people running those, but this thing, when you're building a solid state Tesla coil, all the parts work together. So what works in one person's solid state Tesla coil, not necessarily going to work in yours, because everything else you have in your supply, in your power supply, works with what it came with, pretty much is what I'm saying. It was designed to work with that, but it's hard for me to say designed, because the way the gate drive transformer was wound was just absolutely horrendous. Gosh, if I could find it around here. My example that I could show you of basically how bad this thing was. It's laying around here somewhere. And I don't know. Oh, here we go. Yeah, you can see mine in there. This is kind of what theirs looked like. That's pretty much what theirs looked like to the T. And this actually is the wire that came off of theirs. That's the original wire that was on that. It's solid core, super thin wire. Really just chintzy. But anyway, like I say, by swapping in one component, just because you see that it's a component that someone else put in their coil, that might mean that you have to make adjustments and or redesign some of the other components in your coil for it to work with that new component. So you really do have to be aware. If you do happen to just buy like a kit or one of these China eBay specials, this costs like $180. If you buy one of these or something similar and you decide to modify it, to increase performance, yada yada yada, just be aware of that. And if you're an experienced coil builder, you'll already know that. You change one thing, oftentimes you have to change other things to get them to match up and work well together. The fiber optic controller is pretty nice. The music quality, it will play music. The music quality is Leaves a lot to be desired. This is just a simple interrupter. It's got two 555s in it. It's rechargeable. Uh, Simple phone charger, headphone jack there, power and duty cycle. So basically, your power and then your pulse length. This basically the speed. So it goes from slow to screaming like a two-stroke on steroids. And it's fiber optic, which is it's nice. And I haven't really had any problems with that. It works with an infrared LED, I do believe, emitter in there, and it's just low. I mean, you can't see any light. If you try to look into it while it's on or anything, you can't see it. It's infrared, but it flows down, through this orange uh, fiber optic conduit here, and it's received by the other end, which that is really a nice feature to have. Oftentimes, especially the bigger Tesla coils, they'll have fiber optics like that for safety, because fiber optic, this will not conduct electricity. So the operator holding the control box can't, potentially take a lightning bolt. But even more than that, especially if you're going to play music, this prevents any of the electromagnetic fields, which, as you guys may know, become very high around the Tesla coil. It prevents any interference with the signal going to the coil, and allows you to just control it without having all that noise or interference going on. And I mean, even if it's not a musical Tesla coil, any signal going down a wire is going to be affected by the massive amounts of magnetic flux going on around a Tesla coil. These bipolar Tesla coils, I have discovered, and I'm sure you can find it somewhere if you dig deep enough and read about it, they are not as I don't know, what's the word I'm looking for? They are not as apt to want to light up fluorescent tubes at long distances like standard Tesla coils are. In my understanding, and what I believe is basically this coil, it doesn't need a ground for its secondary, and it basically just talks to itself. And both of the toroid top loads on the sides, let's call them side loads on this thing, basically they just wrap around into each other, and it forms its own little ball of energy there, and it doesn't really want to radiate a long distance. Like, with the same power, if this was a standard Tesla coil, I would be able to light up a light bulb where I'm sitting. I'm sure it would light up a fluorescent, at least dimly. As it is, I have to put it, in the field around the coil, and even then, it surprisingly lights it up rather dimly compared to even my much smaller Tesla coils that I've built in the past. And that's just one of the weird quirks with this thing. And I'm sure it has to do with the topology, it being bipolar. I experimented with different ways of increasing the capacitance on the top loads. I don't know if any of you guys know. If you're an experienced coil builder, you will know that sharp edges, sharp points, anything like that will become a breakout point. You'll lose charge there. You'll leak corona. So that's why these toroids are fat radiused and rounded and smooth. That way they hold the power instead of leaking it off as little fuzzy coronal discharges, because you want all your power to build up and then shoot out your breakout points. So whatever you use, if you add anything, or if you ever build your own top load, like say out of aluminum foil and whatnot, the smoother it is, the better. because you're going to start getting losses. You're going to start having leakage, and that's a loss right there. So that being said, I used baby food lids, and they are completely rounded. On the back side, which would be the top of the baby food lid where I drilled the hole for the bolt to go through, I sanded all the paint off so that it would make good contact with the washer behind it. I did that on both ends with the baby food lid. I want to get full size, pickle jar lids. As soon as I get a couple pickle jars or whatever, as soon as I come across them, I want to put the pickle jar lids and then the baby food lids in the middle, and so it'll be a triple stack of plates with that little plate in behind it, and just see what it does. Really, to be honest with you, I have a scope. I have the ability to get down into the nitty gritty and actually measure the resonant frequency of this coil, the secondary and the primary, and match them up pretty well. Due to the fact that this thing's driven by IC, it has one loop, a feedback wire that goes around with the primary there, which basically is self-tuning. But see, here's the thing. When it says it's self-tuning, it's kind of a misnomer, because here's the thing. If your secondary and your primary, or your primary and your secondary, are completely not on the same page with resonant frequency, and you have a self-tuning feedback winding, yeah, sure, the IC it'll read the feedback, and the IC will do its damnedest to try to drive the primary to match the secondary, but it won't be able to do a very good job of it, because it's gonna hit a lot of resistance. It's gonna have a fight to get them to cooperate, and that's gonna drastically affect your output. That's gonna be one of my next things I'm gonna do. Is I'm just going to take it all apart, which it's frustrating, because you're in there, it's fiddly, I don't really like the way this plastic's kind of semi-delicate. You got a lot of little screws, etc. But really, I just want to know for my own peace of mind. But that being said, all the modifications that I've done, these little additions and stuff like that, really, I knew they wouldn't change the frequency very much. Like adding another turn to the primary coil, that definitely did change the resonant frequency of the primary, as well as adding the however small bit of capacitance to the secondary. That changed both. But if you add a wrap, add some cap. That was my thinking, and the performance is actually much better. Where you see the breakout points now, that's about its maximum. It's still not at its advertised length, which is, ball to ball. Big old loopy. That's where they get the 30 centimeters from. Across from ball to ball is not a full 30 centimeters, but if you count the loop as it is up flickering in the air, I guess that could be a 30 centimeter string, but it's still not going from ball to ball. Very disappointing. I did make some little short, teeny copper, I call them like little bullhorns. I just soldered a ring terminal, just like these were from the factory, but instead of the long wire, I just made little stubby wires. I tried those last night after I got done installing and testing the voltage doubler, and it just wouldn't quite push the arc all the way across. Very close though. So I'm going to continue on modifying this thing, and I might need to get into changing some capacitances on the inside there. just taking things slow. And you have to do, if you've never screwed with a solid state Tesla before, or any kind of power electronics, inverters, stuff like that, you got to do your research. These, you can get one of these kits, or even just a complete unit fairly cheaply, and learn. But I've been doing this kind of stuff for years, and I still blow up parts. I still pop stuff. Last night when I was designing that voltage doubler and putting that in there, I used 2 brand new power diodes. They're gorgeous. SO220 package. They're in the garbage can now because of one simple oversight. They're only rated for 200 volts. So duh, I'm doubling the rectified AC. So I'm getting like over 300 volts in there. So as I'm cranking up the variac, all of a sudden, the variac started humming. It was all of a sudden drawing current. A wisp of smoke came up off of one of the diodes, shut it down. I was like, oh man, okay, where's all this smoke? I didn't see exactly where the smoke was coming from, so I turned it up slowly again and started feeling around for what was getting hot, and sure enough, one of them blew, the other one was good. So then I replaced the one diode with a bigger diode, and then left the other one at 200 volt. Tried it again. Then the second one fried, and then it hit me. It is stupid how it took me burning out 2 brand new, perfectly good power rectifiers that were really high quality. I mean, super fast. They were made for a better purpose than a voltage doubler. They were like, they were made for like ZVS type, very fast switching, not just straight rectification, but whatever. They were what I had. So what I ended up doing is I had one super fat, I think it was a SO247. It was a really fat diode that I got out of, I don't know what it was. It could have been an old TV that I'd taken apart and harvested parts out of. Let's see here. I gotta know. Alright, so the ones I burnt up, I apologize, I'm filming this on my tablet. It's the best camera I have. So this is the bag that the diodes came in that I blew up. They were BYW 29s, 200G. Yep, they were nice, brand new, from Onsemi. And then I had wrapped in tape, and I stuck in the same bag because it's a power diode. It's a hyper Fred epitaxial diode with soft recovery, 30 amp, 600 volt, pretty fast reverse recovery there. Great for snubbers, freewheels, switch mode power supplies, uninterruptible power supplies, induction, high frequency switching. It's completely a beast of a diode. Anyway, so I put that in on one side, and then I, being that I didn't have any more high power rated diodes, and I didn't want to go through all my salvaged parts. I mean, I have other diodes and stuff that I've salvaged out of stuff. I didn't want to go through all that. So I just looked at the data sheet for the full bridge rectifier that I was gonna replace, that I was replacing, that my voltage doubler was taking the place of, and it's good for 1,000 volts and plenty of amps. So what I did is I just took some small heat shrink tubing, sealed off, heat shrank the 2 center pins on the 4-pin full bridge rectifier. That way they wouldn't short out and make contact with anything. And then I just ran, for the second diode, the full bridge rectifier chip, the positive and negative, the two end pins, just ran that as if it was just a single diode, and slapped it all together. The capacitors that I have in there right now are electrolytics. They are, and electrolytics is what you want if you're going to do a voltage doubler in your solid state Tesla coil for your input power, to get your boost if you're running on 120 AC mains. And you really want at least two capacitors in series, 1,000 millifarads or microfarads each. And as you know, capacitors in series, the capacitance of the total in series is going to be less than any one of the capacitors in that series. So right now, what I had and what would fit inside this case, what would work, and that was high enough voltage, was 200 volt, 270 microfarad times 2. So I really need more capacitance, because that capacitance is what holds the high voltage charge, and every single time one of your MOSFETs or your IGBTs fires, boom, it drains that capacitor, the capacitor bank. And so the more capacitance you have, the faster it will recover and the more amperage it can give to that pulse. Because if you have too little capacitance, you're not going to be able to kick out as fat of a pulse as you would if you had more capacitance. So that's definitely something that I need to increase. Also, just the regular bus capacitance that they already had built into this thing, in my opinion, was rather skimpy. It's got 4 Changsun, they're the green low ESR electrolytic caps. There's 4 of them. They're only 120 microfarads, 450 volt rated capacitors, and they're all in parallel. So, that makes for one big old fat capacitor. But man, I would really like to see 2,000 microfarads in there. The more capacitance, as I say, the more you're gonna have to drop for your pulse, and just that alone could account for a lot of the lack in performance. Because they've probably been making these things in China, open source. Who knows how many different manufacturers are copying the same thing, and they get lazy, or they run out of a certain part, or they want to cut corners. And so they just swap out some cheaper parts or some counterfeited parts for the proper parts, and yeah, it'll work, but it ain't doing what the first generation did, and it ain't doing what they're showing in the pictures on their advertisements. And they do that type of shit all day, with all kinds of products from China. I mean, come on. And so that's just kind of something that you have to expect. And either stick to your guns and be ready to do the return. Like with this thing, it was buyer pays for return shipping, which was really lousy. And I took pictures of all the cracked plastic. The box looked like they had played football with it up and down one side of a container ship and in the other. The plastics were all cracked. There was wires broke loose, disconnected on the inside. I sent them pictures of that, and their offer was to send me the plastic pieces to replace it, the broken ones. Also, of course, the beautiful aluminum toroids were all scratched. The secondary coil was all scratched. The tape covering is all wrinkly and peeled in spots. And if this thing was nice, put together the way it's supposed to be, and if it had come the way it was supposed to be, not all shattered and shit, it's a thing of beauty. Tesla coils can look completely Mad Max, or they can look absolutely like like furniture. They can look like, you know, truly a work of art. And at this point, I've given up on that. You know, if I really want to get picky with it, maybe someday I'll cut out my own pieces and just you know, make a clone of these pieces. I have a bunch of plexi over there, acrylic and stuff like that, or even just a shot of paint. You know, the bottom case is actually nice. It's not too scratched up, but you can see in here, this is the hot glue. Looks like shit, and a lot of scratches from the damage and from bouncing around and coming over here from China. It took a little over a month, I think, to get here. But I mean, I could totally paint this top deck, you know, like black or whatever I wanted to, and it would look good. So I will show you guys another video. It'll be video number 2 of the performance of this coil, as it is, like I said, with all the modifications that I've listed. And if you guys have any questions, feel free to hit me up in the comments. I really appreciate it. And yeah, give me a like, give me a subscribe. It really helps me out. You know, it doesn't cost you nothing. And let's see if we can get some more videos rolling here. And eventually, you know, I would like to get into a better camera setup. And you will see my face eventually. There's just weird with, you know, filming on a tablet like I am to swap from front camera to back camera. It actually doesn't even give me the option to do that right now. So I would have to start the video holding my tablet backwards so you could see me, but I couldn't see you because I can't see the screen to even know what I'm actually pointing at. So I hate that type of crap. So anyway, I really appreciate it, guys. This is Shocker Coils over and out for episode 1 of Bipolar Solid State Tesla Coil. Thank you.